Hello, this is about my project CPU Pipeline Simulator. I'm going to go over the project description that I proposed and that was approved first, and then we will go over the README and finally the demo. So, as I proposed, I would design and implement a software-based five-stage pipeline simulator to show how a processor would simulate a pipeline. The model is the classic pipeline stages: instruction fetch, instruction decode, execute, memory access, and write back. And create a small instruction set including arithmetic, memory access, and branch operations. It would include pipeline registers between stages and run cycle by cycle, allowing performance measurement. Beyond this, I would also implement data hazard detection, install insertion, forwarding to show the differences between forwarding and without forwarding. As we know, with forwarding, the current instruction depends on, it sends it directly to the current instruction without sending it back to a register. So, we will also analyze performance, see how, see the cycles, the stall count, and the speed up comparison, and see if it is working as we want it to. This is the README. The README goes over how you could reproduce it and see if it's working, with the instructions that are supported, the features that we have, um, with the one you would need to download, and how you can run this. Now, let's look let's run our demo. Clear this, and I'm gonna run python main.py. As you can see, it's working. We're getting a beautiful CLI interface with options. And right currently, I have no program selected. Forwarding is on by default. I'm gonna do the full run, and yes, we are generating the HTML reports. Okay, so now let's first select a program. Let's test the load use. Okay, the forwarding is on. Run mode is full run, and let's run the simulation. As you can see, let's scroll up. So it assembles 13 instructions from our load use assembly file. These are the 13 instructions with the assembly instruction and the opcode, program counter, and the format. Now if we run the pipeline, this is how the pipeline looks like. Okay, so as you can see, it's kind of we've made the interface out kind of beautiful. So you're able to see this pipeline in action. This is what we see in terms of doing the forwarding. So forwarding, where this would send the instruction directly to the current instruction, the result of the previous instruction. So we get a 1.53x speed up, and then this is the final register state, and this is the data memory state. And this we can also open this up, this HTML file that it generates. As you can see, this is a beautiful HTML file that we're able to see. And yeah, so that's just one. Let's see if the other ones are working too, the other programs. Python, Py, select programs, do data hazards, run simulation. As you can see, it's assembled 7 instructions from our data hazards assembly file. Simulates the pipeline. Forwarding is on. We're getting a 2x speed up. And then we're getting the final register state. This also is saved. If I open this up, as you can see, getting all this nice information. And also we also get the register value trace also. So that's with the data hazards. Now for the last one, let's select the third one and run the simulation. As you can see, we're able to run this. We're able to get 9 instructions from the branch assembly file. The pipeline is running. As you can see, we're able to generate these branches. And we're getting a 1.45x speed up to see the performance, and this is the final register state. Let's look at this also in the HTML page. As you can see, we're getting the program listing, the forwarding on versus off, the differences on versus off. And then we're also getting the performance metrics, 1.4x speed up, and the register value trace. So that's my project. Please feel free to give feedback and any questions you have.